Hello, how to solve this exponential problem? M to the power of m equals m to the power of 2. We are solving for all values of m that satisfies this equation. Now, if you consider this identity, you have a power a and this equals a power 2. Since the bases are the same, you compare the exponent, that means you have a equals 2. Now, going by that identity, you are going to have m equals 2. But this is just one of the solutions because the exponent here, which is 2, means that we are going to have two different solutions. Now we have gotten one solution. Now let's go ahead and solve for the other solution. We have m power m equals m to the power of 2. Let's consider this first method. I can divide this by m to the power of 2. I divide this by m to the power of 2. This cancels this. I'll have m power n divided by m to the power of 2 equals 1. Now consider this identity. You have a power n divided by a power n equals a power n minus n. So if you consider this particular identity, that means you are going to subtract the exponent. You have m power n minus 2 and this equals 1. Now the next thing you're going to do is to apply log of m power n minus 2. This equals log 1. Now if you have log m power n minus 2, this simply means the m minus 2 here will come behind the log. So you have m minus 2 times log m. Now remember, the properties of logarithm are applied to natural log. So while log is to the base of 10, natural log is to the base of e. So I think we can easily make use of natural log here instead of using log. I have ln. I have ln. The reason I'm making use of natural log is because natural log of 1 is 0. So that's why I'm making use of natural log. Now by applying the property, that means m minus 2 will come behind this. So we are going to have m minus 2 times natural log of n equals natural log of 1. And like I said, natural log of 1 is 0. We have m minus 2 times natural log of n equals 0. So at this point, what we can do is to equate each of these to 0. We have m minus 2 equals 0. We have natural log of m equals 0. If you solve this, you will definitely have m equals 2. This is our m1. To solve this, we make use of e. You have e power lm equals e power 0. This cancels this. I have m equals e power 0. And e to the power of 0 is 1. We have m equals 1. Now we have two solutions, m equals 0, m equals 2, and m equals 1. Now we can also solve this problem making use of another method. If you have m power m equals m power 2, I can start by applying the natural log right here. I have ln of m power m equals ln of m power 2. Now remember, if you have ln of a power b, this equals b times ln of a. So the m here will come behind this identity. So you have m times ln of n equals the same thing here. We have 2 times ln of m. Now from here, I can move this over here. It becomes m times ln of m minus 2 times ln of n equals 0. ln of m, I can factor that out. So what I'm going to have will be ln of m times this divide this. I have m minus 2. This divide this will give us 2 equals 0. So can equate each of these to 0. I have ln m equals 0. I also have m minus 2 equals 0. If you solve this, you have e power ln n equals 0. This eliminate this, we have m equals e power 0. And any number or alpha per raised to the power of 0, exception of 0 itself is 1. For this, I move this over here. I have m equals 2. I've gotten two solutions again. Which are m equals 1, m equals 2, just like what we had earlier on. We have m equals 2, and we also have m equals 1. So right now, what we are going to do will be to check for the solutions we have gotten. We have m equals 2, and also we have m equals 1. We have m power m equals m power 2. Did you consider m equals 1? You have 1 power 1 equals 1 power 2, and 1 power 1 is 1 equals 1 power 2 is 1. Both sides are the same. Now let's consider when m equals 2. We have m power m equals m power 2, so we have 2 power 2 equals 2 power 2. 2 power 2, this is 4. And this equals 2 power 2, this is 4. Left hand side equals right hand side. This is also very correct. So ladies and gentlemen, the two solutions have proven to be correct, and we have solved them in different ways. Now, is there any other solution you think that will satisfy this equation? I very much doubt. Is there anyone? If you consider m equals 3, will it satisfy this? Obviously no, because this will give you 3 power 3, and it's not the same thing as 3 power 2. This will give you 27, and this will give you 9. So it's not. No other solutions. If you have any other solution, kindly drop it on the comment box. For what we have gotten so far, m equals 1 and m equals 2. Even 0. 0 is not a solution. Let me establish something here. If you have m equals 0, what you are going to get will be 0 to the power of 0. And this is not the same thing as 0 power 2. 0 power 2. 0 power 2 is 0, but 0 to the power of 0 is indeterminate. So this is not 0. 0 power 0 is not 0. It's indeterminate. So it is different from 0. So that is why the only two solutions we have are 1 and 2. So that is it. Thank you and goodbye.